in confidence intervals sometimes without knowing that, without realizing that. Okay, let me give you an example. Let's say, I mean, I know this is an online class, but I also know that we have classes on campus in the classroom that many students attend, especially before COVID. And I believe next semester we're going back to the way it used to be before COVID. Okay, so now I do know that there are many students that commute to campus. So, so one good example about confidence interval is this. Let's say somebody asks one of the students, "How long does it take you to drive from home to campus?" Okay, that's the question. How long does it take you to drive from home to campus? And you might get an answer that sounds like this. The person might say, "It takes me about 45 minutes, give or take 10 minutes." Okay, I'm going to say that one more time. It takes me about 45 minutes, give or take 10 minutes. What does that person just said? Can someone explain or interpret that for us? I mean, what do you understand that to be? If somebody make that kind of statement to you, anybody, what do you understand that to be? Hello? Are we there? Did you hear me? Can somebody acknowledge that you at least heard me?
Yes, I hear you.
Yeah, I could hear you too.
You hear me? Okay, good. So if you hear me, then I'm saying, can somebody explain that? Just you. I mean, I'm not telling you to talk to me as a statistics expert. All I'm saying is, in everyday conversation, you have. I mean, for a moment, forget about statistics. For a moment, you as someone said, it will take me 45 minutes to get to campus, give or take 10 minutes, or give or take 10. What does that mean? What does that statement mean? Even as a layperson, what does that statement mean? Or what would that mean to you? Is that a complicated response to that question? Did you find that complicated? Because nobody is saying anything.
So it would be between 35 and 55 minutes that you can expect this person to arrive.
Okay, who's talking now?
Lillian.
Okay, could you say that one more time?
Sorry, there's some construction going on, but I said you would expect this person to arrive um, anywhere from 35 to 55 minutes, but like approximately 45.
Okay, so why do you say between 35 and 55?
Because it was give or take 10 minutes.
Give or take 10 minutes, right? Okay, let me take it from here. Thank you, Lillian. Let me take it from here. What the person is saying is, I think it would take me 45 minutes, but I'm not sure, right? Because if you're sure, there's no need for the extra give or take, right? It's because you're not sure. Because you're not sure, what you are doing is you are given an estimate. Okay, you are given an estimate of the time that you think it would take you to get to campus, right? So that is what that's so you're given an estimate, okay? but you say, I'm giving you an estimate, I'm not sure. But even if I'm not sure, if I'm going to be off, it's not going to be more than 10 minutes either way. Meaning that it could be maximum 10 minutes more or maximum 10 minutes less. That's what that means. That statement is a statement of an uncertainty, of an estimate of something. And now you're trying to protect yourself by saying, even if I'm off, right, I'm going to provide a protection of 10 minutes either way. I'm providing a protection of 10 minutes either way. So if it's now 45 minutes, it could be more than 45 or it could be less than 45. But maximum either way will be 10 minutes. And that is why Lillian said that it would take between 35 and 45. Okay? It will take between 35 and 45. Okay. Let me share my screen with you so that we can also look at some stuff that we wrote before. Let me share this. Share. Okay. Okay. So when we speak of confidence interval, the confidence interval could be for the mean, it could be for the standard deviation, it could be for the median, it could be for any of the measures. But let's take the most important one that we are concerned with, which is the mean. So confidence interval for population mean. Remember, sigma, I'm sorry, mu is the notation for population mean, right? So in this context, so we will say mu is we refer to it as population parameter. We talked about this in the beginning. Mu is the population parameter, which is the measure that we calculate from population or the measure that represents the population. So it's a population parameter. Okay. Now, remember that we've said this over and over that in real life, we don't work with population data. We work with sample data. Why? Because population data many times is too expansive, is too big, too big, too, how do I say? Sometimes it's too expensive. Sometimes you don't have enough people to actually do the job. So because of that, you will settle for the sample. So you will take a sample, and what you're trying to calculate from the population, such as the mean, then you do it from the sample. Okay, and so if we're looking for the mean of the population, and we calculate the mean of the sample, if you remember, we use X bar. Okay, we use X bar for the as notation for the sample mean. Okay, and that X bar, we refer to it as a point estimate of mu. Okay, we're using X bar as an estimate of mu. Okay, what is mu? Mu is the population mean. X bar is the sample mean. So we're using the sample mean as an estimate of the population mean, right? Because the sample mean is only one single value, one single number, then we refer to it as a point estimate, the point estimate of mean. And then we also have interval estimate. The interval estimate is the same as the confidence interval. So we have point estimate, which is one single number, one single value. We also have interval estimate, which is the same as the confidence interval, which is the subject of today's class. Okay, so now in trying to obtain the confidence interval for mu, There are two situations. One is sigma is known. Remember, sigma is the population standard deviation. So in some cases, we will know the value for sigma. In some cases, we will not know the value for sigma. Okay, so but in this particular case, we want to address the situation where sigma is known first. Okay, where sigma is known. So we're gonna obtain the confidence interval for mu where sigma is known. Okay, so now before we get to the confidence interval, there's something we call margin of error. Okay, margin of error. Another way to say is to say error bound for a population mean. Error bound for a population mean, well, denoted as EBM, just a shorthand for error bound for population mean, EBM. So that is the margin of error. That is the margin by which you are off, or by which you may be off. Okay. Now tell me this. The example that I just gave, with the assistance of Lillian, can someone tell me what is the EBM in that example? What is the margin of error in that example? Somebody.
10 minutes.
The 10 minutes, right? The 10 minutes is the margin of error, right? That 10 minutes is the margin of error. So if you know the margin of error, then you'll be able to obtain your confidence interval. Okay? If you know the margin of error, you're going to be able to obtain your confidence interval, because the confidence interval is going to be in this form. I'm going to read this to you. I hope you can read it on the screen too. It says point estimate minus error bound, then comma, point estimate plus error bound. Okay, what is error bound? Your error bound is your EBM, okay, which is the same as the margin of error. So your point estimate minus error bound, point estimate plus error bound. If we go back to that example, our point estimate was the 45 minutes that I gave. That is the point estimate. And then minus the margin of error, which was 10. And so 45 minus 10 is 35. And then the same point estimate plus margin of error, right? Plus margin of error. So that is how Lillian ended up with 55 for the second number. So it's between 35 and 55. That is confidence interval. That is your confidence interval. Point estimate minus margin of error, point estimate plus margin of error. So once you have an estimate of the value of the measure, then you subtract your margin of error from it, and you also add your margin of error from it. And that gives you the confidence interval. So you're saying that the true population mean, meaning the actual time is going to take you, is going to be in that interval from anywhere from 35 to 55. That's what it's saying. Anywhere from 35 to 55. That's what the time, the actual time that it's going to take. You don't know, but you're saying it's going to be in that interval. And that interval is your confidence interval. Okay? And what I add here, point estimate minus error bound, point estimate plus error bound, using notation, it means X bar. Remember, point estimate is your X bar. It means X bar minus EBM, X bar plus EBM. Okay, X bar minus EBM, X bar plus EBM. So that is going to be the form of your confidence interval. Remember now, it's an interval. It will never be a single number. Confidence interval, your answer, your final answer is always going to be an interval, meaning it's going to consist of two numbers, right? The lower end and the upper end. Going back to that example, the lower end will be 35, the upper end will be 55. So your confidence, so this is the almighty, the formula or the main formula you need to know for confidence interval. I need to do X bar minus EBM and X bar plus EBM. And that gives me the confidence interval. And with that real life example that I just made up, it will be 45 minus 10 and 45 plus 10. And that's how we end up with 35, from 35 to 55. Okay? Now, in calculating confidence interval, there is something we also need to use, we refer to as confidence level. Okay? You see, when you end up with that interval, now you have to specify how much confidence you have in that interval. Do you have 90% confidence? Do you have 95% confidence? Do you have 98% confidence? Do you have 99% confidence in the interval that you just created? Okay? So what you're saying is 95, that interval that I have, let's say we're doing 95% confidence into confidence level. 95% confidence level means you're going to be obtaining 95% confidence interval. So if we're doing 95% confidence interval, what you are saying is that interval that you just created, that you just calculated, you're saying that 95 out of 100 times, the actual time is going to be in that interval. If I drive from home to school 100 times, 95 times out of the 100 is going to be, the time is going to take me is going to be between 35 and 55. The remaining 5% is going to be due to some unforeseen circumstance or unforeseen circumstances, like a tractor trailer rolled over on the road, and it took like 5 hours before they can clear the road, right? So that would not be between 35 and 55 anymore. That may take you like 2 hours before you get there. Or you had a flat tire on your way, right? You had a flat tire on your way, so you call, maybe assuming you can't change the tire yourself, you call the AAA. They say, oh, it will take us 45 minutes before we get somebody to you, and you waited 45 minutes, and then it took the person another 20 or 25 minutes to change the tire for you, and then you end up getting to school 2 hours or 2.5 hours. So those will be exceptional circumstances, right? But outside that, then it will take you between 35 and 55 minutes. 95 times out of 100, or 95% of the time. Okay, if you say you have 95% confidence in it, so you say 95 out of 100 times, it's going to take you, it's going to be the actual time that it's going to take you will be in that interval. Okay? Or if it's 90% of the time, you say 9 out of 10 times, or 90 out of 100 times, the actual time is going to take is going to be between 35 and 55. Meaning that it could be, it could be 38, it could be 41, it could be 48, it could be 51, it could be 52, it could be all of that. And you're going to have all of those 95 times. The remaining 5 times may be like, okay, one took you like 2.5 hours, another took like 4 hours. Okay, there will be days like that, when things will be exceptionally different. Okay, for this particular concept, most of the time we use 95% confidence level, 90% confidence level, 98% confidence level, 99% confidence level. I mean, if you have 95% confidence, 98% confidence, or 99% confidence in it, I mean, that is you like almost, completely sure. That's what that means, and that is extremely conservative. Okay, which is fine. Okay, so to calculate confidence interval, you need to know what confidence level it is. Okay, there's also something called alpha, which I'm going to introduce shortly. Okay, so That example that I just gave you, you see, goes from 35 to 55 or 45. We obtain the 35 by doing 45 minus 10, and 50, we obtain 55 by doing 45 plus 10. So that's how we end up with 35 to 55. Okay. Um, um, okay. So now let's look at, you see this graph, okay? Because we're going to be dealing with sample, so we know distribution of sample is going to be normal if we apply what do we call it again? Central limit theorem, CLT, right? If we apply that, then it's going to be normal distribution. Okay, so you see this graph right here, and then you see right in the middle of the graph. Okay, you see I wrote one, that is where your confidence level is, or is located, is 1 minus alpha. Can you give me 1 second? Okay, just 1 second. Okay, so the confidence level will refer to that. You see that strange looking symbol? It looks like a 2. It looks like a something else. We that is alpha, not infinity. This is alpha. Okay, so 1 minus alpha is your confidence level. Okay, 1 minus alpha is your confidence level. So if the confidence level is 90%, that means your 1 minus alpha is 0.90. Okay, if your confidence level is 90%, your 1 minus alpha is 0.90. Okay.
Sorry, could you scroll up a tiny bit? I forgot to write something down.
Right here?
Yeah, just okay.
Okay. So the confidence level, it could be 90%, 95%, 98%, 99%, and so on and so forth. Okay. It could also be less than 90%. It could be 80%. It could be 85%. Okay. So it could be any of those. But now I'm trying to set this up for you. So when you're doing a confidence interval, if you're doing like a 90% confidence interval, you sketch this graph and you draw these two vertical lines in the tail of the graph, and the middle of the graph you put your confidence level. If it's 90% confidence level, you put 0.9. If it's 95% confidence level, you put 0.95. If it's 98% confidence level, you put 0.98. Okay? So for 90%, we put 0.9. If the middle is 90%, then you have two tails, right? One tail to the left, one tail to the right. If the middle is 90%, that means those two tails combined will be 10%. If those two tails combined will be 10%, each of the two tails will be 5%. That's why you see 0.05, 0.05. That represents the tail. And the middle one is 0.90. Okay? And that 0.90 is your 1 minus alpha. If that 0.90 is 1 minus alpha, that means the two tails is alpha. Tail to the left and tail to the right, the two combined is alpha. Okay? The two combined is alpha. So, so if the two combined is alpha, each one will be alpha over 2. Do you see the alpha over 2? Each one will be alpha over 2. Okay, and that is why alpha over 2 means divide alpha by 2. And for the example of 90%, that's why we divide 10% by 2. That gives me 5% for each one, and that's why it's 0.05, 0.05. Okay, and your confidence interval now is going to be, you see right here at that point, that is your x bar minus EBM, and the other point here is your x bar plus EBM. Okay, is your x bar plus EBM. Okay, okay. So now with that graph up here, now to obtain again to calculate x bar minus EBM and x bar plus EBM, you're going to ask this question. I'm going to provide the answer to that question. It's something we've done before, but in a different context. And you say, remember we're doing 90% confidence level. I'm repeating the same graph right here. And I'm again putting my 0.9 in here and 0.05 in this tail and 0.05 in this tail. However, the graph above is the graph of X bar. The graph below is the graph of Z. And the question you want to answer is, if I have the graph of Z in this way, and the middle of my graph is 0.90, meaning the probability is 0.90, I have one tail here to the right, which is 0.05, and I have one tail to the left, which is 0.05. The question is, what value of Z from the table would that correspond to? Right? So you have minus Z, and I put a star next to it. It's still the same Z. So this is negative Z star and positive Z star. Okay? So from the table, what will be the value of Z star that will satisfy this setup? 0.90 in the middle, 0.05 the right tail, 0.05 the left tail. Okay? And what value of Z will correspond to that? Can anybody help me out on that?
Positive
How do
Z
we
would
go
be
about that, and what would the value be? Go ahead.
so positive Z would be 1.645 because you're finding Z is less than or equal to 0.95. And then negative Z would be, I think, negative 1.645.
Okay, you are right, except in one place. When you said you find the probability of Z less than 0.95, that part is not true. But everything else that you said is right. What you were saying.
Oh, sorry. Yeah, you're finding the. Yeah, sorry. You're finding the Z value of the probability of 0.95.
Right. You're finding the value of Z that the Z probability of Z less than or equal to that value is 0.95. Actually, that is not. Let me see. Yes, you're right. It will be 0.95. Okay. So this is something we've done before, right, Lillian? We've done it before, but not in the context of confidence interval. Remember when we did normal distribution and sampling distribution, we looked at the table backward to find Z value that would correspond to a given probability. So when you're doing confidence level of 90%, you are dealing with the probability also. It's the probability that is given, except in this case, 90% confidence level means the middle part of the graph, not the entire thing, the middle part of the graph. And then you have the left tail, you have the right tail. If you want to find this positive Z right here, it will be 0.90 and 0.05, and that gives you 0.95. That means the probability that Z is less than or equal to a particular number at that point, that probability is 0.95. Okay, that probability is 0.95. And then you find the Z that corresponds to that. And believe it or not, it's our familiar 1.645. And then for the negative part, if you look it up, you're gonna find the probability here is 0.05. And if you look in the table, the z value where the probability is 0.05, the probability of z less than or equal to that value is 0.05, right? That z value is going to be negative 1.645. I'm going to pause here, and I want someone to tell me, I do not understand what you just did. Can you please do it over? Or someone tell me, you can move on. It is perfectly fine. It is perfectly clear. Which is which? It got to be one of the two, right? Anyone want to speak up? Well, I'm going to continue if nobody's saying anything. Okay, so going back to here, we're looking for a 90% confidence interval, and that's why I drew this graph right here. And that 90% confidence interval is going to consist of two numbers. One of them will be x bar minus EBM, the other one will be x bar plus EBM. But before we get to that, we need a z value, and then we'll repeat the same graph, right, with the same setup, except now we are in z scale, z variable, and we're going to z scale, z variable, and we're going to obtain the value of z from the table. Okay, once we obtain that value of z, and then we're going to use it to calculate. Now, because it is, we're going to be dealing with the sample. Now, I wrote here from CLT, this is what I've just explained. From CLT, X bar is approximately normal, mean equals to mu, sigma equals sigma over square root of n. We learned this in previous class, sample distribution, right? Okay. Now, here is the value for EBM. Remember, we need X bar minus EBM and X bar plus EBM. Here's the formula for EBM. EBM equals Z star times sigma over square root of n. Remember my example, my EBM in that example was 10. I just made it up. But for the purpose of our class, we're not going to be making it up. We have to calculate it. Okay? And to calculate EBM, the formula is Z star times sigma over square root of n. Z star is the same Z that we just talked about. If the confidence level is 90%, we obtain the Z star to be 1.645. Okay? And then once we obtain EBM, remember now, this is the formula I repeat again for the confidence interval. X bar minus EBM, X bar plus EBM, right? Now we know EBM is Z star times sigma over square root of n. That means this formula now changes to X bar minus Z star times sigma over square root of n, X bar plus Z star times sigma over square root of n. Okay? X bar minus Z star times sigma over square root of n, X bar plus Z star times sigma over square root of n. So that is the formula for the confidence interval. Okay? And let's look at this again. X bar is a familiar quantity that we know, a familiar measure we know. That is the sample mean. So that will be given in the problem. Z star you will obtain from the table. Sigma is a population standard deviation which will be given in the problem. And n is the sample size. It will tell you the sample size of the sample. Okay? And then you put all of this together. and that gives you those two values that represent the boundaries of the confidence interval, and that's it. Okay? So now you see right here, I did 90% confidence interval. We just did it with the help of Lillian, that the z-star is going to be for the left side will be negative 1.645, for the right side will be positive 1.645. That's why I wrote plus or minus 1.645. Okay. Now let me now change the numbers. Instead of 90% confidence interval, right? How about if we're going to do a 95% confidence interval? How are we going to, and we need to obtain Z or the Z star. How are we going to set it up? And what would be the value of Z in that case? Anybody? Now we're doing 95% confidence interval instead of 90% that we just saw, right? So now we're going to draw the same normal distribution graph and put a negative Z star and positive Z star, and then in the middle will be 0.95 instead of 0.90, right? In the middle will be 0.95. If the middle is 0.95, what will be the two tails of the graph? Anybody? If the middle is 0.95, what will be the two tails? The two tails will be Lillian. Now we're doing 95% confidence interval, not the 90%.
3.29.
What is
Sorry,
it?
let me just double check that. It would be 3.29 plus or minus 3.29.
First of all, that number will be wrong, but you're going too far. You're not actually answering my question. My question is this: look at the graph that I did, even though I put 9.99. But if that is 0.95, what would be the tail to the right and the tail to the left? I'm talking about those.
Oh, sorry.
Those
It would
tail.
be, if it was 0.95. Sorry, I was looking at the distribution that you have on the screen. But if it was 0.95, the tail to the left and the right would be 0.25.
0.25?
Yeah.
No, that's too much. You didn't mean 0.25. You mean point something else. Now 0.25.
Okay. 0.0.
0.025. It will be 0.025. Right? If it's 0.025, what will be the Z or Z star that we're going to obtain from the table?
It would be 0.9. Sorry, give me a moment.
Yeah, take your time.
So you're going to obtain the Z value for 0.9750.
You're right. You're absolutely right. And that will be?
Give me a moment.
Take your time.
Oh, that would be 1.96.
You're absolutely right again. It will be 1.96. Right? It will be 1.96. So let me show that to you. You see right here? So 90% confidence level, your Z star will be plus or minus 1.645. 95% confidence level, your Z star will be plus or minus 1.96. Do we all know how Lillian obtained the 1.645 and the 1.96? If you don't, you need to know. If you need my help to get it, then I'm more than happy to show you if you didn't get it yet. Okay, if you didn't get it yet, I'm more than happy to show you. For the 95% confidence level, Z star will be plus or minus 1.96. Do we get it or no? Okay. How about 98% confidence level? I want someone other than Lillian to explain to us how to get that and what would the value of Z star be. Other than Lillian, Lillian can go ahead and do it, and everybody else should do it, but I want somebody else to explain it other than Lillian. So I'm gonna give you like 1 or 2 minutes to like set it up. But I'm calling for volunteer. If nobody volunteers, then I'm gonna call your name, somebody's name, and that somebody might be you. Okay, so I want someone to explain to me, other than Lillian, how to go about obtaining the Z star in that case when we're dealing with 98% confidence level or 98% confidence interval. And what would the value of Z be or Z star be? Somebody. Jeanne, you want to go over that for us? Jeanne, okay, go ahead.
So you said what is the Z value for 98%?
Yeah, if it's a 98% confidence level or 90% confidence interval, same thing. So how do you set it up? And then what would it be the value of Z star? You're gonna draw the same graph. What value, what number are you gonna put in the center of the graph?
0.98.
0.98, good. Now what goes in the two tails?
Would it be 0 point would it be 0.01?
Absolutely. Good. It will be 0.01. So you're right so far. Now proceed. Now you go into the table and get me the value for Z.
Is it 2.58?
No. It should be a different number. What is that number? Somebody has got a number different from 2.58.
2.6.
Not. What is it?
2.6.
No. Try something else. But don't guess now. Don't be throwing numbers at me, just guessing at random. Take your time, look in the table.
2.06.
No. This is coming from the table now. I will tell you the good thing is that I'm getting other people participating. Well, even if you didn't get the right answer, but at least you're participating. Now go ahead.
2.58?
No, that was the first number I was given to me. It's now 2.58. Let me give you a hint. 2.58 is higher than the number.
I
It's
can
not
try and
2.5.
explain better how I got my answers if you would like, or
Okay, okay, Lillian, what number do you have? Do you have a number different from 2.58
Yeah.
for that one? What number do you have?
So I have 2.055.
2.055?
Yeah.
No.
I'll try again.
Why you're missing it? Okay, we're gonna have 0.98 in the middle of the graph, right? And based on what Janae said, the left tail will be 0.01. The right tail will be 0.01, right? Okay, so now we need to go into the table with what probability do we go into the table? What probability are you going to take to the table to find the z? Let's say we're looking for the positive z value. What value are you going to go into the table to look for? What probability number are you going to take to the table?
I looked for 0.9801.
No, that is the problem.
Okay.
That is the problem, right? Because what is it?
Would we look for 0.981?
No, you would look for 0.99. Why 0.99? You got 0.98 in the middle, you got 0.01 to the left, 0.01 plus 9 plus 0.98 is 0.99, not 0.9801. You got 0.98, that's a 2 decimal. 0.01, another 2 decimal. You add the two, it will be 0.99. And I think that's why you're not getting the right answer. So you're going to be going with 0.99, and then take a look with the 0.99 and tell me what you got now. With 0.99, we got z value will be what?
2.33.
2.33. It would be 2.33. Okay? Yeah, I think the analysis in the beginning is flawed, right? And that's why you're not getting the right number. Now, remember now, you can also get the negative value of z. You just obtain the positive value of z. If you're going to look for the negative value of z, what probability value are you going to take to the table? Tell me. If you're going to look for the negative value of z, what probability value are you going to take to the table? Anyone? Isn't that going to be 0.01? Remember that is the left tail, right? The left tail, that's where the negative is, right? So the value, the probability value there is 0.01. So you take 0.01 to the table and tell me what you got for Z. What do you get for Z? You take 0.01 to the table. What do you get to the table for Z? Somebody. Marianne? If you take 0.01 to the table, what do you get for Z?
Is it negative 2.32?
Yeah, negative 2.33.
Oh,
Yeah, negative 2.33. And keep in mind that those two numbers are mirror image of each other. One will be negative, the other one will be positive. If you got one, you got the other one. But you can look for either one of the two, whichever one you feel comfortable with. If one is positive, the other one is negative. The left side is always going to be negative, the right side is always going to be positive. But for the purpose that we need it for, the plus or minus doesn't matter. It's the actual number that we need. Why? Because in the confidence interval, we're going to do minus, we're also going to do plus. Okay? So you can look for either one. And again, see, I have it right here. For the 98% is plus or minus 2.33. Now let's go for the last one. How about 99% confidence interval? If we're doing 99% confidence interval, how do we get the Z and what will be the value for Z? Someone tell me. Willie, believe it or not, you've given me the number for that already, except it was wrong when you gave it to me. It was wrong for the one that you gave it for.
2.58?
2.58. It's actually 2.575. Not 2.58. It will be 2.575. Make sure we all understand that and we all agree on that.
Professor, I'm confused because you said with 0.98 we're supposed to add 1.
Right?
So I added 1 and I was thinking that, well, it would be greater than 3.99.
Wait. If it okay, now you're losing me. With 0.98, you put 0.98 in the middle, and then you left with 0.02 that you're supposed to divide up between the two tails. So each of the tail will be 0.01, right? So 0.98 plus 0.01 will be 0.99. And that's why we use 0.99 in the previous one. But in this one, we're doing 99% confidence level. That means we have 1% left to be shared by 2/3, or 0.01 to be shared by 2/3. And that means each of the 2/3 will be 0.005. And that's the exact picture you're looking at right on the screen right now. If you look at the screen, you see the graph you're looking at, you see 0.99 in the middle. That leaves us with 0.01 to be shared between the 2/3. If you divide 0.01 into 2, you get 0.005. And that's the exact picture you're looking at right now.
Okay,
So
so
with that,
for
yes,
point
right.
995,
What is it?
so I'll be looking for 0.995.
Absolutely.
Oh, okay.
Absolutely. Because you add 0.005 to 0.99, that gives you 0.995. And if you now go into the table, you're going to get positive 2.575. Now, Tony, you could also use 0.005, right? Just for the left tail, you can just use 0.005. You use 0.005, and that should give you negative 2.575. And that's how we do that with plus or minus 2.575. So look at this now. Look at the numbers now. For 90%, it's plus or minus 1.645. For 95%, it's plus or minus 1.96. 98% plus or minus 2.33. 99% plus or minus 2.575. Those are the 4 common confidence levels that we use. However, it could be any confidence level that you'll be asked for. It could be 80% confidence level. It could be 85% confidence level. It could be 70% confidence level. Whatever it is, you're going to do it the exact way we did all of the ones. Let's say it's 80%. So that means the middle part will be 0.80. That leaves you with 0.20 to be divided up within the between the 2/3. If you divide 0.20 into 2, it will be 0.10 for each, right? And if you add 0.90, 0.80, and 0.1, that gives you 0.90. Then you will take 0.90 to the table. Okay? So any one of them, you're going to analyze it the same way, but do it the right way. If not, you're going to end up with the wrong number. Okay? Okay, so remember, we have not calculated the confidence interval, but to calculate confidence interval, along the way, you need to obtain Z. And all we've been doing for the last 15 or 20 minutes is how do we obtain that Z if we are given a particular confidence level. And we did for 4 different types: 90% confidence level, 95% confidence level, 98% confidence level, 99% confidence level. We did it for all those 4. But it could be any other number. Okay? So once you do that, once you obtain Z, again, look at the confidence interval formula. X bar minus Z star sigma over square root of n, X bar plus Z star sigma over square root of n. It is this Z star, part of the formula that we just obtained right here, that we obtained up here, that in this formula you're going to need this Z star. And you have to go into the table and find it. The rest of those will be given in the problem. X bar will be given, sigma will be given, the sample size n will be given. The one that you need to obtain yourself is going to be the Z star, which you're going to obtain from the table. Once you have all of those, you put them together, then you obtain a confidence interval. Any question about this process? Okay, so let's look at Okay. Can we take like maybe like 5 minutes break, and then we come back, and then now we look at actual confidence interval question. Okay. If you want, you can. I mean, that's the example I want to go over. You can read it and deliberate on it, and then while we take a 5 minutes break, and then actually let's be back at 2:50. I'm looking at my time here, it says 2:42. Let's be back at 2:50, and then we can continue with this. Okay.
Just need the beach baby. You're still in class? Yeah. Where's the computer? Oh, okay, cool. We're gonna beat you, what you think? Not that much, honestly. Risky. You better put some pants on. Those red pants got my cock is crazy. Ah, yeah, you're cold. Must be nice. Oh my goodness, freezing. It's sexy. Yeah, how about? Oh, no. Oh, yeah, he does. Why does he got love on him? Why is he love gun? Who's loving on him? Huh? Yeah. I think so. Unless you don't wanna. When's the golf cart gonna be fixed? What? When's the golf cart gonna be fixed? Who the hell knows? Really? Where these people move down here? Yeah, facts. I never. Facts. 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 What are my facts? Facts. Have facts. Well, I guess I'm going back outside. I think we might have. Well, today's what? Wednesday? Mm-hmm. Now we have 2 episodes of Dave. Tonight there's another one dropping. Nice. It'll probably be up on Hulu tonight too. Yeah. TBH. Well, it drops at 10. I know, and I think they come out right. That's what I'm saying. 10 on Hulu. So we have two episodes. Dave. Pass. It depends what time we trip, and also depends what time we start watching Dave. Yeah, right. Start watching Dave at 9:30, then yeah, we'll have a second nap. I think it stinks that we got no golf cart. It would have been nice to just take that thing to the beach. Yeah. A little wind in the hair. I know. Should we wait till church tomorrow? Do the golf cart's gonna be ready yet? Probably not. Right? Probably not coming back. Probably not. I think she's out of commish. It's alright, we got my car. Stay in fuck. That's alright, we got my car. Yeah. What do now? Still in class. After we'll hang out on the deck for a little, I guess. We'll make some lunchies and then take another napper, probably. You got lunchies here. You don't need to get lunchies. No, I know. What are you gonna get for lunchies? You got chicken, I guess? What? You gonna go get one, probably? Yeah. Nice. Yeah. I got lunchies. These are so gas. Gas. You're literally so gas. So easy. You want 2 loads or 1 load? Just 1 for now. Whoever Proto lost their cat. It's in orange. They live right next to it. In orange. It's in orange. It lives like literally a block away. I live down the cut down.
Okay.
Cut down street. Okay.
I'm back. And you're back?
Yes. Yeah.
Okay, so did you read the question? And how do we go about this? First of all, what does the question want you to do? Tell me, what do they want you to do? Anyone? What is the main question here? Or what is the core of the question? What is it?
To find the 90% confidence interval.
Right. To find the 90% confidence interval. And I've shown to you the formula for confidence interval, regardless of the percent, right? It is X bar minus EBM, X bar plus EBM. We know EBM is Z star times sigma over square root of N. That means is X bar minus Z star sigma over square root of N and X bar plus Z star sigma over square root of N. Now, if you're in the problem, they give us some numbers. Can we identify each of the numbers that is given? Tell us what are those numbers using their notation. What are the numbers given?
Can I answer?
Oh yeah, anybody.
X bar equals 68.
Thank you. What
standard
else?
deviation or sigma equals 3.
Thank
N
you.
equals 36.
Right. And what is your confidence level?
90%.
90%. Right? You are given X bar. Remember the formula? X bar minus Z star sigma over square root of N. You are given X bar. You are given sigma. You are given N. Right? And you are given the confidence level. With all of that, you can calculate your confidence interval. And let's scroll down a little bit. See, identify X bar equals 68, sigma equals 3, N equals 36, CL equals 90%. Right? Because we know X bar is normal. Why? Because look, look right here. It says, suppose test score in the statistical exam randomly distributed with an unknown population mean. So this is telling you that the population distribution is normal. Therefore, the sample is going to be normal, right? So that's why I said X bar is normal. If X bar is normal, then that gives me the liberty to draw this graph, right? So after drawing that graph, look at what I wrote. X bar minus Z star sigma over square root of N. That is the formula I need to calculate this point. And right over here, the same thing except it's plus, right? So in this setup, all I need to obtain is my Z star. Look, if you go back up here, X bar is 68. So you know that, right? Sigma is 3, you know that. N is 36, you know that. The only thing we don't know yet is Z star. And where did we get Z star from? From the table. And because this is 90%, when we were practicing with Z star, we already obtained that. Anybody remember what that was? For the Z star for 90% confidence level. We obtained that already. Anybody know what that is?
1.645.
1.645. Okay, so again, I repeated the formula here. Okay, now see, I plug in those numbers. X bar, okay, you see the formula right above in the box, right? Right below that, right below X bar, I put 68, right? And then Z star, sigma, I put 3, N, I put 36. And I did the same thing on this side, okay? So what is left for me now is to supply the Z star. And the Z star, we already did it already, is 1.645. Now I plug in the 1.645. Do you see it? 1.645, 3 divided by square root of 36. And then here, 68 plus 1.645, 3 divided by square root of 36. Note that I use comma to separate the two end points. Right? Okay. So now I'm kind of showing how we obtain the Z star. It's 90%, this is 0.90. I'm left with 0.10. You divide 0.10 into 2, that gives you 0.05, 0.05, right? Okay. And so that was how I obtained the 1.645, which we did before. So now you put all of this, you see 1.645 times 3 over square root of 36, that gives you 0.823. So it will be 68 minus 0.823, 68 plus 0.823. You remember my first example, 45 minus 10, 45 plus 10. Remember, I made up the 10, just to illustrate, I made up the 10. But we actually have to calculate the margin of error, which is what we did here, and we obtained 0.823. So it will be 68 minus 0.823, 68 plus 0.823. Okay? And that gives us 67.877, 68.823. Any question about that? Right? Any question from anybody? Your main formula for confidence interval is X bar minus EBM, X bar plus EBM. So we know what EBM is, which is Z star times sigma over square root of N. Right? Z star times sigma over square root of N. Right? And like I told you, N will be given, which is 36 in this case. Sigma is given, which is 3. X bar is given, which is 68. The one you need to find yourself is the Z star. But to find the Z star, that will be based on the confidence level that you are given also. In this case, the confidence level is 90%. Okay? Okay. Now, let me ask you this question. For this same problem, if the question had asked for 95% confidence interval, what are we going to do differently? What would change in this whole calculation, in this whole setup? What would change?
Z star?
What is it?
Z?
Z. Thank you. Everything will be the same except the Z star, right? And what would the Z star be if it's a 95% confidence interval? Marianne, the value of Z star will be what?
Will be 1.96.
1.96. It will be 1.96, and that's what I did right here. Look at the next step. So I change it. So with the 95%, then instead of using 1.645, I'm going to use 1.96.
Professor,
Yes.
for 68 minus 0.823, shouldn't it be 67.177?
Okay. Oh, and I wrote 67.877. Okay. You caught me on that one. And you're right. Sometimes I got too impatient sometimes. So that should be 67.177. Thank you. Was that Tony or Lillian or who was that? Janae?
Yeah.
Okay. Yes, you're right. It should be 0.177, not 0.877. So if you wrote 0.877 already, please change it. It should be 67.177. Okay? Okay. And then for the 95%, it's now 67.02, 68.98. So with the 95% confidence, what you're saying, you see this interval right here. You're saying that 95% of your time, the actual time, that's, well, if I go back to that example, no, not that example. Let's stay with this one. What is the question over here? Okay, so what you're saying is, if you now look at 100 of the students, 95 of them, their score is going to be between 67.02 and 98.98. That's what you're saying. Okay? So now we've looked at 90%, 95%. Okay, if it's 99%, what would change? If it's 99% confidence interval that we're trying to calculate, what would change? I'm here listening. What would change if it's 98? If it's 99%, what would be different?
What point?
Okay, the Z star, and what would the Z star be?
2.5.
No, that's not what we got. 2.5 is not what we got. What did we get?
2.58.
Yeah, too much. What did I write? What did I write? What did I tell you?
2.576.
What?
2.576.
What, 2.576 or 2.575? I think it was 2.575.
Oh, okay.
Right? Because halfway between 2.57 and 2.58. So that's why it's 2.575. Okay? Yeah. So you just need to change that Z star. And then everything else remains the same for this question. Okay? Okay. So any question about how to calculate the confidence interval now? Any question? Okay. Now, let me go back to these numbers here. Look at these numbers again. The Z star. Tell me what you observe, what you notice. The relationship between these numbers and the confidence level. Look at it closely and tell me what you observe. Those Z stars in relation to the confidence level. Tell me what you observe.
The higher the confidence level, the greater the Z star score as well.
You're absolutely right. Just look at it. It's right there. The higher the confidence level, right, the bigger the Z star. Okay. If that is the case, what would be the effect of that on the confidence interval? The higher the confidence level, what would be the effect of that on the confidence interval? We know the Z star gets bigger, right? What will be the effect of that on the confidence interval itself?
The higher the Z star, the greater the confidence interval.
Okay, and I'll use a different word. The wider the confidence interval. Okay. Yes, your confidence interval will become wider and wider as the confidence level goes up. Right? If if you're going to have a 99% confidence, you better make your interval wider. If you want all 99 out of 100 to be in that interval, you better expand it. Does that make sense? If you're going to say almost everything is going to be in that interval, the interval better be wide. So one relationship we love to know, and the typical question on quizzes and tests is, as the confidence interval increases, what is the effect of that on the confidence interval? And the relationship is that of a positive relationship, meaning that as one goes up, the other one increases or is wider. And that's what you're looking at right here. Look right here. Look right here. Confidence level increases. That translates into confidence interval wider. Write this down, make a note of that. I'm going to ask you that question on the test. As the confidence level increases, it translates into confidence interval wider. And vice versa. As the confidence level decreases, the confidence interval becomes smaller or becomes narrower. So the two of them, they go in the same direction. If one goes up, the other one goes up. If one goes down, the other one goes down. So they have a positive relationship. They move in the same direction. If one goes up, the other one goes up. Right? If one goes up, the other one goes up. So they move in the same direction. So you need to know that relationship between the confidence level and confidence interval. Note the reason the confidence interval is wider. Somebody tell me, we just said it already. What is the reason that the confidence interval becomes wider? What is the reason the confidence interval becomes wider? It's because the Z star is getting bigger, right? The higher the confidence level, the bigger the Z star. And the Z star gets bigger, then your interval is going to be wider. So the reason the interval is wider is because your Z star is getting bigger and bigger as the confidence level increases. Okay? So make note of that relationship. Let's look at a second relationship. And to do that, I'm going to write the EBM formula again. What is the EBM formula again? EBM formula is Z star times sigma over square root of n. That is the formula for EBM, right? Okay. Let me ask you this. You see, this n represents the sample size. Let me ask you. If we increase the sample size, let's say from 36 to 70 or 36 to 50, what do you think the effect of that is going to be on the EBM? If we increase the sample size, let's say it was 36, now we're going to increase it to 50, what would be the effect of that on the EBM?
The EBM gets smaller.
The EBM gets smaller. Thank you. Why?
Because when you divide by a larger number, so you're dividing sigma by a larger number if you're increasing the n, and so when you're dividing by a larger number, it gets the sigma gets smaller.
The sigma gets smaller?
Or sorry, my bad. The sigma divided by that number gets
Meaning, whenever you have a fraction, which is what we have, when you have sigma over square root of n, you have a fraction. Whenever you have a fraction and you're dividing the fraction by a bigger number, that's going to make your fraction smaller. For example, 1 over 10, and then you change it to 1 over 100. That whole fraction gets smaller. You change it to 1 over 1,000. The fraction gets smaller again. So anytime you have a fraction as the denominator, the divisor, as it gets bigger, it's going to reduce the entire fraction. So sigma over square root of n becomes smaller. That is a fraction. As you increase your n, that becomes smaller and smaller and smaller. Okay? It becomes smaller and smaller and smaller. So when you increase your sample size, you're decreasing your fraction. As you decrease the fraction, that means you're decreasing your EBM. What is the effect of that on the confidence interval?
it gets narrower.
It gets narrower, right? When you increase the sample size, your confidence interval gets narrower. See, n increases. When I do this arrow, it means it implies or it translates into confidence interval narrower. So you want to know the relationship between the sample size and the confidence interval. And vice versa, by the way. So as if n decreases, the confidence interval gets wider. So the sample size and confidence interval have an opposite relationship. They move in opposite direction, right? They move in opposite direction as n increases, as sample size changes. So if one goes up, the other one goes down. So they have inverse relationship. Okay, they have inverse relationship. One goes up, the other one goes down. They move in opposite direction. They move against each other as if they are fighting each other. However, the first one, which is the confidence level, they move in the same direction. They are best of friends. They go parallel. They go hand in hand, right? One goes, the other one follows. But the second one, with the sample size, they fight each other. They go in opposite direction. Keep that in mind. They go in opposite direction. So we want to know the relationship between confidence level and confidence interval. Okay? We know those two go in the same direction. They are best of friends. They are buddies. However, the sample size and confidence interval, they're not buddies at all. They fight each other. They go in the opposite direction. One goes one way, the other one goes in the opposite direction. Meaning, if the sample size increases, confidence interval gets narrower or smaller. If sample size decreases, confidence interval gets wider. Why is that? Because you have a fraction. And when you divide a fraction by a bigger number, then the fraction becomes smaller. You see, all of these explanation, if you ask this question, you have to provide that. Okay? Any question about those two relationships? No? Okay. There's one more thing that we need to do about this, but maybe I want you to digest this, everything that we did tonight, and then tomorrow, then we can finish that part of it. Okay? We can finish that part of it tomorrow. Now look at the top here. I've assigned some problems here. I'm looking for it. Look, so for the homework, Page 483, numbers 95, 97, 99, 101, 103, and 107. Okay, again, page 483, numbers 95, 97, 99, 101, and 103. And no, 103 and 107. Okay? Let me stop right here. And there's just one little part that is left on this confidence interval, and we will do that tomorrow. Okay? And we will also go over the test 2 tomorrow also. Any question? If no question, then I'm going to stop the class officially, but I'm still going to hang around. If anybody has any question, feel free to ask me.
Thank you.